Our next lesson is called the recursive formula for arithmetic sequences. At this time, please pause the video and try the opening exercise. When you're ready to go over the answers, you can resume the video. Okay, so at this point, you've completed the opening exercise. Consider Kristen's sequence 5, 8, 11, 14, and 17. A says, if you believed in patterns, what might you say is the next number in the sequence? Looking up above to me, it looks like it's going up by 3s, so after 17 would be the number 20. In B, write a formula for Kristen's sequence. So this that I'm showing you here, formula, I want you to think about the explicit formula that we learned for arithmetic. So I used that formula and substituted 5 in for the first term and 3 in for the common difference. Don't forget to state where n is greater than or equal to 1. And in C, explain how each part of the formula relates to the sequence. A sub n would represent the nth term. 5 is the first term in the sequence, n is the term number, and 3 is the common difference. So when Johnny saw the sequence, he wrote the following. He did a of n equals a of n minus 1 plus 3 for n is greater than or equal to 1, and a sub of 1 is 5. If you look at the difference between this, there's a slight difference in notation. First thing we want to describe is what does the a of n minus 1 mean? This stands for the term before. So think about that. If the current term was n, if you wanted to know what came before it, you would have to go back one term. That's why they're saying n minus 1. So it's the term before a of n. So let's look at the following arithmetic sequence. Same one you were looking at above, 5, 8, 11, 14, and 17. Want to go over some symbolization here and how to write it in terms of a sub n minus 1 and d with common difference, and then we'll go ahead in the last column and put down the numbers. So the first term you are aware of being a sub 1. Second term is a sub 2, so we continue that pattern all the way up to a sub n. We can keep going and going and going. In terms of a sub n minus 1 and the common difference, let me show you how this is going to stack up. The first term is still exactly the same, a sub 1. Now, instead of writing a sub 2, we're going to use the term before a sub 2, which would be a sub 1, to define it by saying then we'll take a sub 1 and add the common difference. Instead of writing a sub 3 for the third term, I'm going to use the term that came before it, because remember, n minus 1s mean the ones that came before it. What came before a sub 3 was a sub 2 plus the common difference to get a sub 3. And we follow this pattern. A sub 4, I'm going to use the term that came before it, which is a sub 3 plus the common difference. And if I continue that pattern, what you're seeing is you take the term before, a sub n minus 1, and add the common difference. So if I were to look at it with our numbers, our first term was a 5. In order to find a sub 2, I'm going to take the first term, which is 5, and I'm going to add the common difference to it to get 8. To find the third term, I'm going to use the second term, which is 8, add the common difference of 3 to get 11. So then, again, what you're doing is taking the term before and adding 3. Okay? Underneath, if you want to find a term, a sub n, and you have the term before it, a sub n minus 1, you can use what's called the recursive formula. So that's what we're doing right now, is defining this sequence recursively. There's two options for the formula. I'm going to give you both of them. First one, a sub n equals a sub n minus 1 plus d. So remember, this is the nth term is equal to the previous term plus the common difference. Now, if you decide to use this formula, you actually have to say for n is greater than or equal to 2. Because remember, we need 1 and up, and because we have this n minus 1, a 2 would have to be there so that this at least is the first term. Our second option is very similar. It's just more looking into the future rather than looking into the past. So here it was the nth term or the current term. You can also use that language if you want to add current here, if that helps. Okay. The current or nth term is equal to the previous term plus the common difference. Your next option is to do a sub n plus 1 equals a sub n plus d. So now this is going to stand for the next term. So you're using the next term is going to be the nth term, or again, current, plus the common difference. Here, it would be for n is greater than or equal to 1, like we are used to. So either the nth term is the previous term plus the common difference, or the next term is the nth term plus the common difference. These are all called recursive formulas. So does the formula that Johnny wrote represent the sequence? If we look back up here, Johnny wrote the nth term is the previous term, right? A of n minus 1 plus 3, and 3 was most definitely the common difference. So now we see the answer here is yes. And we'll say it is the recursive formula. So now we're going to look at some examples together in practice. Consider a sequence given by the formula a sub n equals a sub n minus 1 minus 5, where a sub 1 equals 12 and n is greater than or equal to 1. Now, even before I go back and do that, over here, I want to come back to Johnny's sequence and point something out that's important. If you're going to give the recursive formula, you must give the first term. We cannot use this recursive setup if we don't know what we're starting with. So in example 1, you will see that that happened right here. A sub 1, or the first term, was given to us. So our sequence again is a sub n equals a sub n minus 1 minus 5. So remember, that's the nth term is the previous term minus 5. That's the common difference. So our first term is 12. They told us that. In order to get the second term, remember what that means. I'm going to use the term that came before it, which is a sub 1, which is 12, and I'm going to use the common difference of minus 5 to see that a sub 2 is 7. To get a sub 3, I need to use the term that came before it, which is a sub 2, which is 7, and then the common difference to see that a sub 3 is 2. A sub 4, I'm going to use the term that came before it, which is a sub 3, which is 2, and I'll use the common difference of minusing 5 to see that a sub 4 should be negative 3. And a sub 5, use the term that came before it, which is a sub 4, which was negative 3. Use the common difference and see that that's negative 8. So if I was going to list all of them, I would have 12, 7, 2, negative 3, 8, negative 8, dot, 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 to show that it continues in that pattern. So now let's take a look at the difference in formulas. We want to write a recursive formula for this situation. So we already had the recursive up top, the a sub n equals a sub n minus 1 minus 5. So I want to write it in the other notation. We could look at this as the next term is the current or nth term minus 5. And then remember, we have to say n is greater than or equal to 1 for that. Now for write an explicit formula, that's going back to the explicit formula we used for arithmetic a while ago. So a sub n equals, we always write the first term, which is 12, plus n minus 1 is always staying there, and then the common difference goes at the end, which is negative 5. Again, for n is greater than or equal to 1. And then up here, along with the n is greater than or equal to 1 for the recursive formula, we also have to define the fact that the first term is 12, because I cannot use the recursive formula if I don't know what I'm starting with. In part D, it says find a sub 6 and a sub 100 of the sequence. So for the first part of this question, a sub 6, I have to think to myself, do I want to use the recursive formula or do I want to use the explicit formula? Well, it depends. If I'm looking for the sixth term, I have to say to myself, do I know the fifth term? If I look up to my previous question, I do know the fifth term. The fifth term is -8. So I'm going to use the recursive formula of a sub n plus 1 equals a sub n minus 5, because then I know the sixth term is going to be the fifth term minus 5. So the sixth term is a sub 5, if I go up and look, was -8 minus 5. So now I know a sub 6 is -13. Now, if I wanted to find a sub 100, what would I want to use? The recursive formula or the explicit formula? So again, you have to ask yourself, do I know the term that came before it? Well, a sub 100 means I need to know a sub 99. We do not know the 99th term. So here, it makes more sense to use the explicit formula, a sub n equals 12 plus n minus 1 times -5. So to find a sub 100, I'm going to put 100 in n spot. So that means I'm doing 12 plus 99 times -5. And if I figure that out using my calculator, I end up with -483. So we've already talked a little bit about this, but we'll formally answer the question in Part E. Which formula did you use for Part D and why? So we used the recursive formula for a sub 6, since we knew a sub 5. Whereas in the explicit formula was used for a sub 100, since we do not know what the 99th term is. So at this time, I'd like you to try out a few on your own. For each sequence below, an explicit formula is given. I'd like you to write the first 5 terms of each sequence, then write a recursive formula for the sequence. So at this time, pause the video, try the 2 questions, resume the video when you're ready to check your answers. So for number 1, a sub n equals 2n plus 10 for n is greater than or equal to 1. So if I wanted to know what a sub 1 is, I would put 1 in n spot, and I would see that a sub 1, 2 times 1 is 2 plus 10 is 12. A sub 2, I would put 2 in n spot, which means a sub 2 is 14. If I find a sub 3, I'm going to put 3 in n spot, which means a sub 3 is 16. So I have enough now to stop finding it that way and see that the first few terms are 12, 14, 16. And now I can go over and do my recursive formula. I'm going to use the next term is the current or nth term, and I'm going to take a look at my pattern and see that I'm adding 2. So I'm going to add 2, and I'm going to say for n is greater than or equal to 1, and a sub 1 equals 12, making sure I give the starting point and saying what I'm allowed to use. So now I can finish the last 2 by just following the pattern, 18, 20, ... So there's the first 5. Here's your formula. For number 2, I did the similar thing. To find a sub 1, I plugged it in for n, and a sub 1 is -1. I did the same thing for 2, and I got a sub 2 equals -3. And then I did the same thing for 3. And I got that a sub 3 is -5. So I started to write the pattern, -1, -3, -5. And then I take a look at it, I'm going to write my formula. A sub n plus 1, so the next term is the nth term. If I look at that, it's going down by 2. So -2 for n is greater than or equal to 1, and a sub 1 equals -1. So that's my formula. And now I can fill in these last 2 terms, -7, -9, ... And that concludes your lesson on recursive formula for arithmetic sequences.